That's in my zone 15 feet, but
This should not take too long. I wanted to give you something a little bit more fun. I really, like I said, I thought those assignments became a bit flavorless after a while. Those of you that blew through 24, 25 in the practice quiz kind of felt probably like that, like it was just kind of rinse and repeat. So there'll be a little bit of newness on this one. What's today's the 10th? And this is just a quick review of some factoring things. I would have taught you this type of factoring in Algebra 2, but you're going to see it again on this. So I thought it would be fun. Maybe not fun, but something fresh. So we'll just call this like a factoring review, I guess. The kinds of factoring that you've been seeing on the last few assignments have been generally either just differences of squares, like simple ones like x squared minus 4. Right. And you guys all know like that's x plus 2, x minus 2. And then you've been seeing a lot of the simple quadratic trinomials like x squared plus x minus 30, which again, pretty simple would be x plus 6 times x minus 5. So I wanted to refresh your memory on a couple of other things. Number one, I wanted to remind you that quadratics can have more than one variable in. So, for example, let's say I gave you something like x squared minus 16 y to the fourth. It's weird, but is it a difference of squares? It is. By definition, if you're a difference of squares, if you pass the three tests, if you have a minus in the middle, you're a difference. Test one passed. If the thing before the minus is a square, i.e. square rootable, you pass. And if the thing after the minus is a square rootable, you pass. So something like this that may be outside of our like real close comfort zone, we can still factor. What's the square root of x squared?
X.
What's the square root of the green blob?
4.
Or y squared. So like anything that's a difference of squares can be factored following a pattern. So it's just square root plus square root times square root minus square root. I wanted to refamiliarize you with that idea that no matter how odd or different it looks, if it passes the three-step test, is there a minus? Is that a square? Is that a square? If all three in a row are yes, then you proceed to factor, regardless of what it looks like, regardless of how many variables there are, right? Okay. You can also say the same thing about quadratics, things that look like just normal quadratics. So if I gave you something like x squared plus 3xy minus 28y squared, you look at that and go like, whoa, like this isn't what's going on here. But let's think about what this would look like if the y's weren't there. So if you had no y's in this problem, it would just say x squared plus 3x minus 28, right? Which, by anyone's standards in this classroom, we would agree is simple, childishly simple, right? What would this factor down into? This one.
7.
Yeah, light work, right? X plus 7 times x minus 4. Well, some magic happens if you add an extra variable in a very particular spot. So if I took my x plus 7 and I made it x plus 7y, and then I took my x minus 4 and I made it x minus 4y, you probably have been down this road with me before, but watch what happens when we multiply this out. The first part doesn't change. Like what's x times x?
X squared.
Yeah, it's still x squared. But that's not the cool part. The cool part is, what does this red one make?
-4 x.
It makes negative 4xy. That's where that term comes into existence, is that magical placement of the extra variable caused that term to exist. And then what about these ones in the middle? What do they make? Plus 7xy. And there's our like terms, just like we would normally be accustomed to. So that's where the plus 3xy's come from. And then in the back, of course, what do those make?
28y squared.
Negative 28, but with a yy, so y squared. So I just want you to be aware, like when you see that extra variable pop in today, it's still just quadratic-y thinking. Like we're just still following the same factoring skills that we have. We're just getting a little bit creative is all. And then the last part of this, the one I was a little bit the most maybe leery of was the cubes. So do you guys remember these formulas? Short set, long set. Every one of you took algebra 2 from me. So you've all seen these before. So there's a short set and a long set that go with cubes. So we have a plus b, a squared minus ab plus b squared. And then the other flavor of the formula you'll remember was a minus b times a squared plus ab plus b squared. Is that ringing any bells?
Yeah.
So where the short set and the long set come from is they are the factors that you get when you break down a pair of cubes. And what's nice about cubes is cubes go both ways. Squares, you have to have a minus in the middle or it's like no go, pump the brakes. But with cubes, you can go either way. And so the top formula that you see is a cubed plus b cubed. And notice that the plus that is in the original expression, I was going to say problem, but it's like an expression, carries over into the short set. And what we remember for some of you 2 years ago, for some of you last year, what we remember about this is that the short set long set has exactly one minus to give. And you either spend it right away or you spend it in the middle of the long set. And so if I do a plus, a sum of cubes, then I use my plus right away, which means I have to use a minus later on down the road, right? And then the other formula is, of course, for a cubed minus b cubed. And you'll see in that case, again, that the first sign in the short set is mimicking the original expression. So if the original expression has a minus, then the short set gets the minus. And at that point, you then kind of go, I'm done with my minuses, and then it's pluses for the rest of the way. So let's, now that you've seen this before, so now that it's a little fresher in your mind, let's factor a couple of QB pairs. We'll start with a simple pair of cubes, like x cubed plus 27. And remember, it's not like squares. You don't have to look and see, do you pass the minus test? There is no first test. With cubes, it's just, are you a cube and are you a cube? And if the answers are both yes, then you're green lighted to press on. And you might also remember about me, it's been a hot minute, that I'm a big proponent of you guys writing down what A and what B are. So can you tell me what A is in this particular problem? It's X. It's the cube root of what you see. Or from another perspective, it's what you need to cube to get what you see. So since I want X cubed, it's obviously X that you have to cube to get it. And then what's the B value? 3, because it's the cube root of 27. You give me a room full of kids that are willing to follow those directions, and I'll give you a room full of kids that are almost never going to miss these, because this isn't a much do you or don't you understand it thing. This is just a plug and chug formula thing. So if I ask you to factor x cubed plus 27, then you build your skeletal template. You build a short set and a long set, and you just drop stuff in. You just airdrop it in. And there's a little bit of math that you got to do sometimes along the way, but it's very simple. What would my short set in this case be?
X plus 3.
A plus B, x plus 3. How do we lead off long set?
X squared.
A squared, which in this case is x squared.
Minus.
Good job. You got to pack the minus. And if you don't pack it early, then you pack it in the middle late. Good.
Minus 3x.
And it would be minus 3 times x, right? And that's where we just mash A and B together, right? And you wouldn't want to say something, offensive like x3, right? We don't do that. And then what's at the back end? Plus 9, right? Okay, so let's do one more pair of cubes and then I'll get out of your way and just kind of let you work. Like I said, I whipped up a second practice quiz. I wanted to have a little more control over the second practice quiz. So this one will look different because I actually made it in Word. I didn't want to give my trust over to the computer program for another go. I wanted to have some say. So let's do something a little bit more challenging, like 64 x cubed. No, we can't because 67 is not a cube, but nice try. Minus 100.
It's not like you.
Again, the fact that it's a minus is not what I'm interested in. What I'm interested in are these cubes. And the answer is yes. And there was once a point where we did this a lot, where you knew your cubes really, really well. But it's one of those like use it or lose it kind of things. Let's see how far we can go as a class naming cubes. I don't know how this will be interesting. I get the first one. 1. All right, what's the next cube? Nope. 8 is the next cube because it's because it's 2 to the third. So remember, we don't want squares, we want cubes. Who's the next cube? 27. After 27, 64. After 64, 125. After 125, 216. After 216, 343. There was once a point where you knew these, just FYI. After that, 8 cubed.
It was on the paper.
It was on a paper, but I still think you knew it better than you think you did. 512. I wouldn't be surprised if you do. I've got 8 cubed is 512. Anyone want to take a shot at 9 cubed?
9 times 9, 31.
729.
729. Now we're cooking. And then I'm not going to ask you, well, I'll ask you 10 cubed. 1,000. So remember, the cubes are ours to recognize. We look at the numbers and we're not looking for 4, 9, 16, 25. We're not looking for squares. Once we know we're in Cubeville, then the numbers that we're interested in, that whole list just changes completely, right? Good. So we recognize these as cubes, either with our cheat sheet, and I have more copies if you guys want one, a fresh sheet, but we recognize these are cubes. The 64 is a cube, and the x cubed is, of course, a cube, and then 125 is a cube. And again, plus minus, no matter. So what is A? It is 4x. Thank you for saying x. And what is B? Correct. So again, once I've got those component pieces, it's just a matter of plug them in. This will be a little bit more missable than the last one, just because there's a couple spots where people tend to make little boo-boos. So I am going to do what I always do. I'm going to build a short set and I'm going to build a long set. It's always what I've done. It's always what I will do. So we begin. Short set is what? Good job. So sign mimics. Then this is the one where we don't do any math at all. We just copy down A and B and we mimic the sign from the original. So it's a minus. That tells us now that we've spent our minus, so we're pluses throughout. So no more worry about that. This is the spot usually where people make boo-boos. What's going to go right there? Yeah, and again, this is I heard, I don't think one of you said the wrong thing. Back in the day when we were originally learning, we would have said things like 4x squared, but you guys are like, nah, you can't fool me again. Remember, you square the whole a value, which includes the 4, so you get 16x squared. Nice job, everybody. What goes in the middle? Plus 20x, and at the back end, plus 25. And that's it. So that's how you factor cubes. So in this practice quiz, you're going to see a mixture of, there'll be some pretty ho-hummy problems, but then there'll be some with multiple variables, some with some cubes. So I wanted it to feel a little bit more fresh for you. So if you're still back monkeying around on the other stuff, just please get that done. Like you should be well done with 24 and 25 and easily into the practice quiz. If that's not the case, you're not a bad person. You're just behind. So get caught up, okay? All right, well, I'll leave the recording alive, and then I'll just I'll unpause it if anyone wants to go over some stuff. Yeah. Oops, did I hit resume? I sure did. Nice. Hey, in number 1, I don't know. Like maybe this was a bit of a sneak attack to put this on here, but what you should do on problem 1, I mean to tell you your business, but I think you're going to find this whole problem to just feel neater and easier to follow if you just go straight across the top and multiply all the junk together. So if you go straight across the top of problem 1, just find mates for everybody. The 2 and the 6 make 12. The x is to the third, but he looks for a mate. And he sees later on down the road, he's like, hey, there's an x to the 1 over there. So when they join forces, they make x to the power of 4. And I'm still just going across the top looking for mates. There's a y, and I'm going alphabetically. That y to the first power at the beginning, he has no mates. And we're not going to the bottom. We're just going straight across the top. So I'm just going to put in a y. And then the z to the 5th at the very back, he also has no mate. And then I'm going to do the same thing on the bottom. Just going to mash up. So across the bottom, there's a 3 and a 10 that, of course, find each other and multiply to make 30. And then the rest of it, there's no mates. There's just stuff you want to organize a little bit. So like I'm going to take y to the 5th and put it first, just because it comes in the alphabet before z. And then I'll put z to the 4th at the back. Back in algebra, years ago, you and I talked about properties of exponents and how to simplify things with exponents. So let's start with the part that has nothing to do with high school. Let's just reduce 12/30. What can those both be divided by?
Two.
Do better than 2,
Two.
please. Yeah, if we divide them both by 6, here's what we know. 12 is going to become a 2 and 30 is going to become a 5. So the way I try to phrase this always when I teach this at any level is your answer is going to have those numbers in those positions regardless of anything else that happens. Clear? Now we're going to simplify our x's. And the way you do that is you look for x's in the top and the bottom. And if you have some in the top and the bottom, what do you do with their exponents? You subtract them. Good memory. So the x to the 4th on top has no one on the bottom. So like this kind of a moot point because normally I'd say x to the 4th, go find your mate downstairs and you guys subtract your exponents, but there is no one. So x to the 4th is just going to stay put. Now let's take a look at the y's. What's the y exponent on top? It is 1. It's the infamous invisible 1. And let's do some basic math. If you take the y exponents top to bottom and subtract them, what is 1 minus 5? So you'll remember that when you get a negative for a would-be exponent, you don't make it negative, you make it a bottom dweller. So the properties of exponents tell us, first off, it's really, really bad juju to leave negative exponents on things. So if we're about to get a negative, then we go, whoa, 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 I'll just put you in the bottom instead, right? And be positive down there. And then let's do the same thing with our z's. We're looking at 5 minus 4. What's 5 minus 4? And since it's positive 1, I'm going to put z to the power of 1 on top. There's another way to explain that suits very literal people better. Like you could lay all the y's and you could lay them out. So like here's y to the 1, and then here's y to the 5th. And you're all bright people. So when you look at those y's, how many of them cancel? 1. So if I cancel out this 1y and one of these, you see what's left, that there's 4 left on the bottom, right? So the properties of exponents aren't just like witchcraft that some bearded guy in a cave invented. Like they make logical sense. And the same could be said for the z's. If you do 5 z's side to side, and then you do 4 z's side to side. So these properties, so to speak, are just natural occurrences that we found a way to memorize in a little bit of a shorter fashion. So again, the logic is, well, if I cancel out those z's and those z's and those z's and those z's, there's 1 z left, just like we surmised on top. So hopefully that rings some bells. You can flex on that again in problem number 7 when you get there. So, all right, I'm going to pause again. Let me know if you need more assistances. Oh yeah, this is the final answer like that. And we know it's done when there's nothing else that could be simplified. There's no reduction. There's no things that are the same that need to be put together, whatever. It's done, done, done. Yeah, man.
When you define zeros on number 4. How
Yeah.
do you do that for the x squared plus 3x?
It's funny because as I said to I'm always having, not in a crazy way, like not in an institutionalized me way, but I'm always having conversations with myself while I'm having them out loud with you. And the moment I said, I need you to find the excluded values, I was doing an over under, like I was betting in Vegas on how many minutes until Sutter asks me about the excluded values on the cube problems. You did not disappoint, good sir. Don't worry about the excluded values on number 4 and number 6 and number 8. You can, how about this? Find the ones you want, but then the other ones are going to be imaginary or irrational. So, and I'll show you what I mean, Sutter. So like if you and I wanted to find the excluded values for x squared, you never disappoint.
Javea Lerwick, please go back to
Your
Mr.
questions
Cooper.
never disappoint. Normally you would factor this down and say where are the bad guys, right? But since you can't, you'd have to use the quadratic formula to figure out where this equals 0. So you'd have to say, okay, the bad x's are equal to -3 plus or minus the square root of 3 squared minus 4 times a times c all divided by 2a. Is this ringing some bells? And 9 times 4 is 36, and 9 minus 36 is negative 27. So you'd have negative 3 plus or minus the square root of negative 27 all over 2. And then you would simplify the square root of negative 27 down into 3i root 3, because it would have been root 9 root 3 with a negative in there. You still with me?
Mhm.
And then I would Dorito this down. So I'd have negative 3 plus or minus 3i root 3 over 2. And when I Dorito those three numbers in there, never mind. I can't Dorito them because they can't all be divided by anything. So if you really wanted to go full bore proper on this, on number 4, you could find all your normal, easy to spot excluded values. Then if you wanted to just kind of flex on the math gods and go next level, you could say that negative 3 plus or minus all of this, those are also excluded values. But I don't want this to become a quiz on the quadratic formula, which is why if on the ones that have cubes, if you just want to kind of dodge those, I wouldn't mind that one bit. Okay, bud. Thanks for asking. Appreciate you.
One of the ones that we have to do like